Hi, this is Rashmi Bhatt and we are going to see the sheet photopolymer plate making today. So it begins with the structure of the sheet photopolymer. The sheet photopolymer has a polyester backing sheet and then it has a large chunk of photopolymer layer and it comes with a protective cover sheet. And after exposure and processing, it becomes something like this, which is seen on the right side. So there is a character A which you can see here. So this area is the image area, wherein when ink is put, it will print on the substrate. So there is a base area known as floor. It is slightly in depth, whereas image area is raised. So these raised areas are known as relief. Whatever height to which it is raised, that is known as relief. And the total thickness of the plate is called as caliper. And you can see also here plate backing and the shoulder. If you see the material of the photopolymer, they are made up of monomers and UV initiators. So these monomers, when they are exposed to UV light, they undergo polymerization reaction. There is UV initiator which initiates the polymerization process on exposure to UV light, and after that the monomers get cross-linked to form a chain polymer. So it becomes solidified and it becomes cured. The thickness which is used in flexo print industry is ranging from 1.14 mm to 6.35 mm. So it depends on the job for which it is finally going to be used. It may be a label, it may be just a paper substrate, or it may be a multi-layered structure like a CFB, that is corrugated fiber board, or a multi-wall paper bag. So depending on the job, the thickness varies. The thick plates generally are used for the corrugated post print and the multi-wall bags. So these are the steps in photopolymer plate making process. The first step is the back exposure. So there are 3 exposures in the plate making process along with the all processing stages. So in the first step, that is known as back exposure, the back side of the plate is exposed to UV light. So why we do this is to form a solid base for the image area. So we have seen the floor. So to create that floor, hardening of the floor, this is given. So after that, the second step is the main exposure. So to perform the main exposure, you have to remove the cover sheet and you have to keep the negative or the mask on the photopolymer plate. So when we keep this negative, the emulsion side should contact the plate material so that there is no optical error because of the diffraction of the light. So again we ensure that it is held firmly with the use of vacuum. And here you can see the main exposure process. When the UV light falls on the plate, actually it doesn't directly fall on the plate, there is a mask or there is a negative. So in the negative, the image areas are open. So through these image areas, the light goes. Wherever it is blocked, the light is blocked. So whenever the light goes into the photopolymer, it creates that polymerization reaction, and we can see the color change here wherein the polymerization has taken place. Whereas in the other areas, the material remains soft. So this soft unhardened material is removed in the next step, that is known as the washout step. So using the brushes, because the material is sticky, using brush and solvent, the uncured material is removed from the plate structure. So we can see the blue layer here, or the blue layer is a backing layer, and there is a floor, that is because of the back exposure, and on the front side this is because of the main exposure. So after doing the washout, we have to dry the plate, because otherwise the plate will absorb the chemicals and then it becomes swollen. So we use hot air dryer, and after the drying process, again one more exposure is given, that is known as post exposure. So this is to stop the polymerization reaction. Finally it will stop, or whatever unhardened material remains, that is exposed, and it has to stop the polymerization reaction. And finally there is a UV germicide lamp exposure to give the light finishing. This removes the surface stickiness of the plate. So we'll see the exposures in detail. The first was the back exposure. So we have seen that this is given to create a plate floor. That is the base on which the image area can be formed. So if you see the equipment here, there are multiple light sources. On the cover also we can see the light sources, and on the back side also we have the light sources, and we have multiple trays to do the other steps. We have light finishing, post exposure, and the drying process. So these trays have different facilities to perform all these steps. So coming to the main exposure, so in this exposure we have to selectively expose the image areas. So we use the UV light through a mask or film. The image areas are hardened while the non-image areas remain unpolymerized, so that can be washed away using the solvent. So if you see the picture here, there is a cover sheet, that is a transparent sheet being used. When the vacuum is applied, the sheet ensures that the materials will not move when we apply the vacuum. So first we will put this transparent film on top of the plate and the negative, and this sheet is stuck firmly on the equipment, and after that vacuum is applied, so it ensures that there is no gap between the two materials. Because the vacuum may not work properly on the plate and the film, this cover ensures that they don't move, because the cover will not allow the movement between two materials. So this way the vacuum is applied and then UV exposure is given, and the hardening of the image areas happens here. So the post exposure is after the processing stage. So UV light is again exposed on the plate to cure the plate completely. So we can see the light sources being used for this plate making process. We have three types of light sources. Within the UV, it is divided into UVA, UVB and UVC. So UVC is having minimum strength. So it comes in the range of 180 to 280 nanometer wavelength. So this is generally used for light finishing process. UVB is not used for any of our plate making exposures, which is in the range of 280 to 320 nanometers. But UVA is very important. It is comes in the range of 320 to 400 nanometer. The back and the main exposures are given using the UVA. So as we have seen the plate making process, we will see here what happens if we do not control the exposures timings properly. So the first case we see here is the too much of back exposure. So what happens here is we want to create a small base for the plate, the hardened photopolymer layer on the bottom side of the plate, but because of the higher exposure timing, the hardening has reached a higher level. So what happens is it creates a less relief depth between image area and non-image area. There should be some considerable difference that is reduced because of these wrong exposures. So in the second case we see the back exposure given is less. So we are giving the proper main exposure, but the back exposure is less. So because of this, there is a layer of material which is not at all exposed to UV light on both sides, and it is not reachable by the developing chemicals also. So what happens is within the structure there is some uncured flexible layer, so it creates instability in the plate. Then the third case is inadequate back and face exposures. So there is a large uncured layer because even the front exposure, the main exposure is not proper, back exposure is also not proper, and the processing chemicals cannot reach here. So finally it remains there, but it is not cured. So it is not hard, it is not stable. So the plate is not usable in this also. The fourth case is of too much of face exposures. So if you give more than required amount of main exposures, apart from image areas, it starts acting on the other areas also. So even the other areas become hardened and they start filling in. So there is a problem in differentiating between the image and non-image areas. So this is some brief explanation about the plate making process. I hope this will be useful for you. Thank you.